Hi, thanks for watching this video. This presentation is aiming to introduce an overview of my PhD studies. My PhD studies is currently ongoing in University of Klagenfurt and in ATHENA laboratory. Here I'm going to talk about end-to-end quality of experience evaluation for HTTP adaptive streaming, which is also the title of a short paper recently accepted for publication in ACM Multimedia Doctoral Symposium 2021. This study is ongoing under the supervision of Professor Timmerer and Professor Lux. My name is Babak, and I hope you enjoy this talk. The content of this presentation is divided into few sections: introduction to the topic, following by the raised research questions. The research method and procedures will be discussed next, and then the publications alongside the state-of-the-art studies will be covered. I will also provide a research plan with defined milestones and conclude with the summary. Here we will briefly review the concept of HTTP adaptive streaming, or in short form HAS. In order to deliver the highest possible quality of the media in a streaming session, HAS suggests to break down the media file into multiple segments and represent them in multiple qualities. You can see in the left side of the shown figure the available representations that the origin server is providing, and on the right side a client is shown which selected few media segments from different representation and in different points of time. The selected media segments are supposed to be what is the best according to their network conditions in that moment. This mechanism offers an adaptation to the network link, therefore an optimized delivered media quality. According to the current bandwidth provided by the network and its conditions, a user or a client has the option to select the most suitable representation for the next media segment to be downloaded. The main goal here is to minimize the rebuffering or stall events and increase the media quality to the highest possible value, thus delivering the quality of experience, or QoE, in the best form. We will go through the definition of QoE in the upcoming slide. Quality of experience, or in short form QoE, is often predicted by measuring metrics such as a startup delay, stall events and their duration, and the media quality itself. And it's by definition the degree of delight or annoyance of the user of an application or service, which is in our case HAS, or HTTP adaptive streaming. It should be mentioned that the quality of service has its own measurement factors and metrics, but it can also affect the quality of experience with a linear relation. For instance, transmission delay, that happens to be an important factor in calculation of QoS, is not considered when predicting the QoE, but it could cause a rebuffering or a stall event in the streaming session and directly affect the predicted and also perceived QoE. QoE score is usually referred to as mean opinion score, or MOS, with a range of 1 to 5. QoE models such as ITUT P1203 or P1204 can predict the MOS values, but in order to understand the perceived QoE, one should conduct subjective evaluation, which involves real subject's opinion. There are three main questions that are aimed to be studied around and finally being addressed. First, how to define, implement, and deploy end-to-end QoE for HAS deployments at a scale. Investigating the possibilities of how to assess a video streaming session is the key here. Second question is to how to develop a QoE-driven, context-aware, and collaborative HAS environment. The context of the streaming session, for instance live streaming or VOD, video on demand, or the streamed content type itself, requires to be treated differently. We will use the streaming session assessment result to provide highest QoE according to the session context. The last question to be studied is how to utilize various information from end-to-end aspects to enhance HAS deployments. Content consumption, which is a function of media players and their performance, can affect the streaming session QoE score. We will investigate the improvement possibilities here, for instance, the possible improvement over the ABR algorithms. As our research methodology, we will conduct quantitative research, by which means the findings and results of the studies will be presented in form of quantitative values and metrics. We will use both subjective and objective evaluations during this research study to evaluate the introduced tools and methods. Therefore, this is an experimental research approach. We hire an iterative and incremental approach when designing, developing, and evaluating our novel tools and models, and the cycling loop over the three phases continues till we can assure that the discussed research questions are fully answered. There are three state-of-the-art viewpoints that I have selected for today's talk, and you can see the references to the related articles on the right hand side of this slide. In the context of HAS, QoE has been surveyed. In the first reference here, survey of quality of experience of HAS. According to our literature studies with respect to the taxonomy of HAS, QoE influence factors are categorized into perceptual and technical influence factors. The second reference addresses concepts and challenges for QoE management and multimedia services in general. And the third article categorizes the QoE into modeling, monitoring, and management, and further investigates each category. In the next three slides, I will briefly introduce the publications that are toward finding answers for the research questions in this study. First, CADVISE, which is a cloud-based adaptive video streaming evaluation framework. This testbed, which is first presented in a paper published in MMC's 2020, can be used to run a series of experiments for assessment of media players and their ABR algorithms in a cloud infrastructure. It has a modular architecture, as it's shown in the figure, and consists of three main components: the application itself on the top, the cloud infrastructure like AWS for instance, and the analytics dashboard, which presents the experimental results and significant metrics for our studies. I will talk about this testbed in the next publications as well. Second paper that I wanted to introduce to you is titled Understanding the Quality of Experience of Heuristic-Based HTTP Adaptive Bitrate Algorithms. It has been published in Nostov 2021 workshop and is available for free to be downloaded in ACM Digital Library. To assess the performance of a set of ABR algorithms and better understand how do they perform and make decisions in different network conditions, we have designed 4 network profiles, namely ramp up, ramp down, fluctuation, and stable profiles. We then used CADVISE, the testbed that I have talked about in previous slide, to conduct experiments and aggregate the significant metrics for each media player or ABR algorithms. We have evaluated in total 7 ABR algorithms as it's shown in the figure: Fast MPC, Elastic, BBA0, Quetra, Bola, Dash.js, the default ABR algorithm for Dash.js, and Shaka Player. You can see in the left side the average stall event duration or rebuffering durations for each ABR in different network profiles, and on the right side the average startup delay for the mentioned ABRs and on their different network profiles. We have also used 4 different test sequences in this study that you can read in the paper. Third and last paper, which is in-depth studies on stall events and quality switches and their impact on the QoE in HAS, has been published by IEEE Access also in 2021. Here we have tried to study the stall events and media quality switches from 4 different aspects. We evaluated the minimum noticeable stall event duration in a streaming sessions, and the result is shown in the right side figure. We have found out that stall events with less than 4 milliseconds duration was not noticeable for our subjects, and the noticeable trend is reduced when the duration of stall events is increased. We have also studied the effect of stall events versus quality switches in this paper. Another aspect of QoE in HAS that has been investigated is the effect of multiple short stall event versus a longer stall event on the perceived and predicted QoE. We also evaluated the relation of a stall event impact on the QoE with the provided video quality. Since we have conducted both objective and subjective evaluations, we have also presented the correlation of these two types of evaluation and did a comparison between the state-of-the-art QoE models. You can see the results of this comparison in the left figure for ITUT P1203 by QPS and FINAS QoE models with our subjective evaluations. So the research plan, I have started my PhD studies in January 2020, and by January 2021 I have presented the proposal or expose of the study. The literature review, as you can see, is an ongoing task to be assessed in all the defined milestones. And in January 2022, I have planned to start writing down my thesis, and the research will continue till January 2023 while still writing my thesis. Once the findings and results are satisfactory for the research questions, and all of the research question has been answered, I will finish the thesis writing and hopefully will submit the final documents by March 2023. To summarize my presentation, I would like to highlight the important covered topics here. We have introduced the HAS technique following with an overview of the quality of experience. We have discussed the raised research questions and also reviewed the research methodology. Finally, the publications and the related state-of-the-art works in this field has been presented. Many thanks for your attention, and I wish you a very good time ahead.